Hello, my dear students. Welcome to Sankalp Learning Classes. Today, we are going to solve the metals and non-metals, the important questions. Okay. So, already we have solved the important questions from the MCQ 1 mark and the 2 mark questions. In this video, we are going to solve the 3 and 4 mark questions. That is very important for your board exam, and that will be very helpful for your last minute preparation, because I have included the all the important questions from the model question paper and the old question paper. Okay, yes, let us start with the first question. Draw the diagram of the arrangement of apparatus to show the action of steam on metal. Label the following parts: metal sample, hydrogen gas. So this is the 3 mark question that you have to label. Okay, so you have to draw the diagram and also you have to label this. So one of the important question for your exam. Yes, this is the diagram. So here you have to label the metal sample. Metal sample is given here. Metal sample and the hydrogen gas. Hydrogen gas, you have to label it. Okay, please practice this. Second question. Write the differences between the calcination and roasting. How is pure zinc metal will be obtained by this process? Here, while writing the difference, calcination and the roasting, you have to write the difference. So make the two columns like this. Make the two columns like this. Here, calcination and here the roasting. Calcination and the roasting. Then you have to write the points. Okay. Here, roasting involves the heating of the ore lower than its melting point in the presence of air or the oxygen. So that is the roasting. Calcination involves the thermal decomposition of carbonate ores. So then roasting is carried out mostly for sulfide minerals, and during the calcination moisture is driven out from an ore. Roasting is carried out mostly for the sulfide ores, and here calcination that is used for the carbonate ores. Okay, so that difference you have to write. Next, how to obtain the zinc from the sulfide ores, right? So that is the by this calcination and the roasting process. Here, the metals in the middle of the activity series such as iron, zinc, lead, copper are moderately active, and these are usually present in sulfide or carbonate ores in nature. It is easier to obtain metal from its oxide as compared to its sulfide and the carbonate ores. So you have to convert the sulfide or carbonate ores into oxides. Therefore, prior to the reduction, the metal sulfides and carbonates must be converted into metal oxides. Here, the sulfide ores are converted into oxides by heating slowly in the presence of excess of air. So that is known as the roasting. And the chemical reaction takes place during the roasting and calcination of the zinc ores. So that is given here. That is roasting process. Zinc sulfide ores in the presence of oxygen. So when it is heated, it will convert into zinc oxide and the sulfur dioxide. Then zinc carbonate ores, ZnCO3, when it is heated, roasting, zinc oxide will be formed. Here also zinc oxide will be formed. So that is the zinc oxide. Then the metal oxides are then reduced to the corresponding metals by using the suitable reducing agents such as carbon. For example, when zinc oxide is, so that is treated with the carbon reducing agent carbon, so it is become reduced metal zinc. So here reaction is given. So zinc oxide what we have obtained, so that is treated with the carbon, that is the reducing agent, so which forms the zinc and the carbon monoxide. So here pure zinc is obtained by this process. Okay, here also the equation is given. So in this method, the zinc ores are zinc ores are obtained by this process. Okay, calcination and the roasting method. Here mainly zinc carbonates. So that is in that form, calcination process is used to convert the oxides, and roasting, that is the zincs for the sulfide ores. Okay. Next question. What are alloys? Name the constituent elements present in the bronze and solder metal. What are alloys? Please note down the question. This is also 3-mark question. Name the constituent elements present in the bronze and the solder metal. Here, an alloy is the substance by mixing two or more elements, at least one of which is a metal, to create a material with specific properties. So the alloy that is made by the mixing of two or more elements. So here copper, that is made up of copper and the tin. Here bronze, which is made up of copper and tin, and solder, that is made up of the lead and tin. Next question. What are ores? Write the respective methods used to convert sulfide and carbonate ores of metals into their oxides. What are ores? Note the question. Write the respective methods used to convert the sulfide and carbonate ores of the metals into their oxides. Here, minerals which contain high percentage of particular metal and metal can be extracted from it. It is called ores. Calcination and the roasting. So these are the processes that is used for the uh, carbonate convert into their respective oxides from the carbonate and the sulfide ores. Okay, calcination for carbonate ores and the roasting, that is the sulfide ores. Calcination, that is for the carbonate. Okay. Next question. Draw the diagram of arrangement of upper touch to show the action of steam on the metal. That is the same question what we have solved before. This diagram, that is very important and most repeated question. Okay. Yes, next one. Here also same question. Draw the diagram of arrangement of apparatus to show the action of steam on the metal and label the metal sample. So just I kept this question to show how many times it is repeated. Yes, 3 to 4 question paper. If you refer old question paper, in 3 to 4 question paper it is repeated. Okay. Next question. 250 ml of water taken in each beaker A and beaker B. About 5 gram of sodium metal is added to the beaker A and 5 gram of calcium metal is added to the beaker B. What are the reasons for the observation that you have been noticed here? Here, so both are the 250 ml containers. 250 ml containers. So here 250 ml water is present and here also 250 ml. So here you have to add the metal, sodium metal and here calcium. Sodium and the calcium metals. So when you add the sodium to the water, so it reacts with water vigorously, means it catches the fire because sodium is the highly reactive metal which reacts with the water very fastly and vigorously and which catches the fire by forming the sodium hydroxide. And here in the beaker B, when the calcium metal is added to the beaker B, when the calcium metal is added to the beaker B, calcium metal is added, then calcium hydroxide and hydrogen gas will be released, but the calcium is floating on the water. Okay, so here the hydrogen released is not enough to catch the fire, but the calcium that floats on the water. So this is the reaction what takes place. What are the observation? Here, calcium is floating on the water because of the hydrogen gas, and sodium that react with water vigorously and catches the fire because sodium is the highly reactive metal. Okay, so these are the reaction you can observe there. Next question. What are ionic compounds? Write any four properties of ionic compounds. Okay. Please note down the question. What are ionic compounds? Write any four properties of ionic compounds. Yeah. An ionic compound is defined as the compound formed by the oppositely charged ions which attract each other to form a chemical bond. Next question. The characteristics of ionic compounds, physical nature. Ionic compounds are solids and are somewhat hard because of the strong force of attraction between the positive and the negative ions. These compounds are generally brittle and break into pieces when the pressure is applied. Melting and boiling points of the ionic compounds have high melting point and the boiling points. This is because considerable amount of energy is required to break the strong interionic attraction. Next characteristic, solubility. Here, electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene and the petrol. Here, conduction of electricity. When the ionic compounds are in the molten form, they are able to form the ions and they conduct the electricity. But when they are in the solid form, so they do not conduct the electricity. Next question. Name two metals which are kept stored in kerosene oil and write the four physical properties of the metal. Please note down the question. Name two metals which are kept stored in the kerosene oil and write any four physical properties of the metal. Here, sodium and potassium, so they are highly reactive metals, so they are kept stored in the kerosene oil. Write any four properties of the metals here. Metals are malleable and ductile, so they have the malleability and the ductility. Metals are good conductors of heat and the electricity. Metals are lustrous, means they have the shiny and can be polished. Metals are solids at room temperature except mercury, which is a liquid. Metals are tough and strong. So these are the some physical properties of the metals. Next question. Draw the diagram arrangement of the apparatus showing the electrolytic refining of copper and label the acidified copper sulfate solution. Please note down the question. Is here. Acidified copper sulfate solution. Yes, this is the acidified copper sulfate solution. Next question. Explain how do metals react with solutions of other metal salts with example. Explain how do metals react with solutions of other metal salts with example. Here, reactive metals displace the other metals from their solution. For example, iron displaces the copper from its sulfate solution. Okay. So, for example, the reactive metals, I will take the iron plus copper sulfate. So, with example, you have to explain. So, here iron sulfate is formed and copper is displaced because copper is having the less reactivity than the iron. So iron is able to displace the copper from its solution. That is the answer. Next question. You must have seen tarnished copper vessels being cleaned with lemon or tamarind juice. Explain why these source substances are effective in cleaning the vessels. Please note down the question, one of the important question for your exam. Here, copper reacts with moist carbon dioxide in air to form the copper carbonate and as a result, copper vessel loses its shiny brown surface forming green layer of the copper carbonate. The citric acid present in the lemon or tamarind neutralizes the basic copper carbonate and dissolves the layer. That is why tarnished copper vessels are cleaned with lemon or tamarind juice to give the surface of the copper vessel its characteristic luster. That is the answer. Next one. Differentiate between metal and non-metal on the basis of their chemical properties. Okay. On the basis of their chemical properties, you have to differentiate that. Here, metals are electropositive. Metal combines with the oxygen and form the metallic oxides. And metallic oxides are bases. And metallic oxides are insoluble in water, but some oxides soluble in water and forms the alkalis. Metals react with water and forms the metallic oxide and the hydrogen gas. Again, metallic oxide dissolve in water and forms the metallic hydroxides. Again, last one, metal produce the chlorides. These are electrovalent or ionic compounds. Non-metals react with metals and gain the electrons and forms the cations. Most of the non-metals dissolve in water and forms the acidic or neutral oxides. Non-metals do not displace hydrogen from the dilute acids. Non-metals react with hydrogen and forms the hydrides. Next question, you are given a hammer, battery, a bulb, wires and switch. How do you use them to distinguish between samples of metals and non-metals? Assess the usefulness of the test in the distinguishing between the metals and the non-metals. Yes, here with the hammer on beating the sample, if it changes into thin sheets, that is the malleable, and then it is a metal. Otherwise, it is a non-metal. Similarly, we can use the battery, bulb and wires and a switch to set up the circuit with the sample. If the sample conducts the electricity, then it is a metal, otherwise a non-metal. Okay, so the above tests are useful distinguishing between metals and non-metals as these are based on physical properties. No chemical reactions are involved in this test. Please note down the answer. Next question. Yes, so this question already we have discussed. So tarnished copper vessels, how it can be cleaned using the lemon or tamarind juice. Yes, this is the correct answer. Already we have solved this question, right? Okay. Next we are going to solve the 4-mark question. Okay. Here, first question is explain the extraction of zinc metal from its sulfide ores. Show the formation of sodium chloride molecule by transfer of the electron. Here each question carries the 2 marks. Okay. Each question, A question for 2 marks and B for the 2 mark. Here roasting involves the heating of ore lower than the melting point in the presence of the air or the oxygen. Calcination involves the thermal decomposition of carbonate ores, and here we are using the roasting is carried out mostly for sulfide minerals. During the calcination, moisture is driven out from an ore. Next, here So here, prior to the reduction, the metal sulfides and carbonates must be converted into metal oxide, because obtaining the metal from its oxide is easier than the sulfide ores. So here the roasting process is involved. So here the after the roasting, yes, this is the when the roasting process, zinc sulfide, when it is treated with the oxygen, it forms the zinc oxide and the sulfur dioxide. The metal oxides are then reduced to the corresponding metals by using the suitable reducing agents such as carbon. For example, the zinc oxide, here zinc oxide, when it is treated with the reducing agent carbon, which forms the zinc and the carbon monoxide. Okay, that is the answer. Next, second question here. Show the formation of sodium chloride molecule by transfer of the electrons. Show the formation of sodium chloride molecule by the transfer of the electrons. Yes, this is the question. Sodium chloride is formed by the transfer of the electrons. So this you have to practice, okay? Next question. Depict the formation of magnesium chloride with the help of electron dot structure, and hydrogen gas is not liberated when the metal like zinc reacts with the nitric acid. Why? Here also each A and B question that carries the 2 marks. Okay. Here, yes, this is the formation of the magnesium chloride. Please note down the answer. Here, hydrogen gas is not liberated when a metal like zinc reacts with nitric acid. Why? Here, because nitric acid is a strong oxidizing agent, it oxidizes the hydrogen and produce the water and itself get reduced to any of the nitrogen oxides. Next question. Explain the formation of ionic bond between the sodium atom and the chlorine atom, and list any 4 general properties of ionic compounds. Yeah, first one already we have solved. Yes, this is the formation of the sodium chloride. That is the formation of ionic bond between the sodium and the chlorine. And list any 4 general properties of ionic compounds. Hello, my dear students. In this video, we are going to solve the 3 and 4 mark questions from this chapter, that is metals and non-metals. Let us start with the first question. Draw the diagram of the arrangement of apparatus to show the action of steam on the metal. You have to label the metal sample and the hydrogen gas. Yes, this is the diagram. Okay, one of the important question for your exam. You have to label the metal sample as well as the hydrogen gas here. Next question. Write the differences between calcination and roasting. How the pure zinc metal will be obtained by these processes. Okay. Here, roasting involves the heating of ore lower than its melting point in the presence of oxygen, in the presence of air or oxygen. Calcination involves the thermal decomposition of carbonate ores. Roasting is carried out mostly for sulfide minerals. During the calcination, moisture is driven out from an ore. Here, the metals of middle of reactivity series such as iron, zinc and lead, copper are moderately reactive. These are usually present in the sulfides ores or the carbonate ore in nature. It is easier to obtain the metal from its oxide as compared to its sulfide and the carbonate ores. So, the zinc sulfide or zinc carbonate ores are converted into zinc oxide, into their oxides. Okay. Here, the sulfide ores are, so they are converted into oxide by roasting process, and the carbonate ores, they are converted into oxide by the calcination process. Okay. Then roasting, so that is the process involves the zinc sulfide. When it is react with the oxygen, it forms the zinc oxide and the sulfur dioxide. The metal oxides are then reduced to the corresponding metals by using the suitable reducing agents such as carbon. For example, when the zinc oxide, so when it is zinc oxide is treated with the carbon, that is the reducing agent, that forms the zinc and the carbon monoxide. Next question. What are alloys? Name the constituent element present in the bronze and the solder metal. Here, what is first one? What are alloys? An alloy is a substance made by mixing two or more elements, at least one of which is a metal, to create the material with specific properties. Here, bronze, which is made up of copper and tin, and solder metal, that is made up of the lead and the tin. Next question. What are ores? Write the respective methods used to convert the sulfide and carbonate ores of metals into their oxides. Here again, how the sulfides and carbonate ores are converted into their oxides, that question is asked. Minerals which contain high percentage of particular metal and metal can be extracted from it is called ores. So here carbonate metals that can be extracted by converted into oxide by calcination, and the sulfide ores that can be converted into oxide by roasting process. Okay. Next question. Draw the diagram of arrangement of apparatus to show the action of steam on a metal. Draw the diagram of arrangement of apparatus to show the action of steam on a metal. Here, yes, this is the diagram. This is the most repeated question. You can see. So if you see the old question paper or model paper, it is repeated 3 to 4 times. So please practice this diagram. Next one. 250 ml of water is taken in each beaker A. and the beaker B and a beaker B, about 5 gram of sodium metal is added to the beaker A and about 5 gram of calcium metal is added to the beaker B. What are the reasons for observation that have been noticed here? When the sodium is added to the water, it reacts with water vigorously and catches the fire by forming the sodium hydroxide because sodium is the highly reactive metal. Then when the calcium react with the water which forms the calcium hydroxide and the calcium that floats on the and there is no fire is found because less amount of hydrogen is released which is not enough to catch the fire. So that is the answer here. Hydrogen released in the calcium when it is when the calcium react with the water, the hydrogen release that is not enough to catch the fire. Very less amount of hydrogen is released. So reaction you can write like this. Okay. Next question. What are ionic compounds? Write any four properties of ionic compounds. Okay. Here we have already solved the what are the ionic properties of ionic compounds. Here, ionic compound is defined as the compound formed by the oppositely charged ions which attract each other to form a chemical bond. Then here, physical nature. Ionic compounds are solids and are somewhat hard because strong force of attraction between the positive and the negative ions. These compounds are generally brittle and break into pieces when pressure is applied. And melting and boiling points. Ionic compounds have high melting points and the boiling points. This is because considerable amount of energy is required to break the strong interionic attraction. Next question. Solubility. Yes, electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene and the petrol. Then conduction of electricity. Here, when these compounds in the molten form, aqueous form, then only they are able to form the ions and they carry the electricity. When it is in the solid form, when they are in the solid form, they are not able to conduct the electricity. Next question. Name two metals which are kept stored in kerosene oil. Write any four physical properties of the metal. So name the two metals here, sodium and potassium. They kept stored in the kerosene oil, and the physical properties of metals are they are malleable. They have the property of malleability and ductility and good conductors of heat and electricity. And metals are lustrous and can be polished. Metals are solids at room temperature and except the mercury which is liquid. Metals are tough and strong. Next question. Draw the diagram of arrangement of apparatus showing the electrolytic refining of copper and label acidified copper sulfate solution. The diagram, here you have to label the acidified copper sulfate solution. Practice all the labelings in this diagram. Next question. Explain how do metals react with the solutions of other metals salts with example. Explain how do metals react with solutions of other metal salts with example. Here, reactive metals displace the other metals from their solution. For example, when the iron react with the copper sulfate, it forms the iron FeSO4 solution plus copper. Okay, so that is the answer. Next question. You must have seen tarnished copper vessels being cleaned with lemon or tamarind juice. Explain why these source substances are effective in cleaning the vessels. Here, copper react with the moist carbon dioxide in the air to form a copper carbonate. As a result, copper vessels loses its shiny brown surface, forming a green layer of copper carbonate. Then, the citric acid present in the lemon or tamarind neutralizes the basic copper carbonate and dissolves the layer. That is why tarnished Tarnished copper vessels are cleaned with lemon or tamarind juice to give the surface of the copper vessel its characteristic luster. Next question. Differentiate between the metal and non-metal on the basis of their chemical properties. Okay. Yes, this is the characteristics of metals. And this is the characteristics of non-metals where when react with the metals gain the electrons and forms the cations. Most of the non-metal dissolve in water and forms the acidic and neutral oxides. Non-metals do not displace the hydrogen from the dilute acids. Non-metals react with hydrogen and forms the hydrides. Yes, these are the next question. You are given hammer, a battery, bulb and wires and switch. How could you use them distinguish between samples of metals and non-metals? Assess the usefulness of these tests in distinguishing between metals and non-metals. Here with the hammer on beating the sample, if it changes into thin sheets, then it is the metal, otherwise a non-metal. Similarly, we can use battery, bulb, wires and switch to set up the circuit with the sample. If the sample conducts the electricity, then it is metal, otherwise a non-metal. The above tests are useful in distinguishing between the metals and non-metals as these are based on physical properties. No chemical reactions are involved in this test. Yes, this question already we have solved. Next, we are going to solve the 4-mark question. Explain the extraction of zinc metal from its sulfide ores. Only sulfide ores they have asked here. Transfer of electrons. Okay. Here roasting process is involved. The metals of middle reactivity series such as iron, zinc, lead, copper are moderately reactive. So these are usually present as sulfides or carbonate ores in nature. It is easier to obtain the metal from its oxide compared to sulfides and the carbonate ores. So here the sulfides, zinc sulfides are heated in the presence of oxygen. It is converted into zinc oxide. That process is known as a roasting. Here you can see the roasting process. This process is the roasting process. Then the metal oxide then reduced. So this metal oxide that is reduced by using the reducing agent such as carbon. Here zinc oxide in the presence of carbon that is reduced to zinc and the carbon monoxide is formed. Yes, this is the formation of sodium chloride. Please note down the answer. The question is, show the formation of sodium chloride molecule by transfer of electrons. By transfer of electrons. Okay. Next question. Depict the formation of magnesium chloride with the help of electron dot structure. So this is the first question, 2-mark question. Second one, hydrogen gas is not liberated when a metal like zinc reacts with nitric acid. Why? Here, because nitric acid is strong oxidizing agent, it oxidizes the hydrogen and produce the water and itself get reduced to any of the nitrogen oxides. Explain the formation of ionic bond between the sodium and chlorine atom. That is the 2 mark question. And list any 4 general properties of ionic compounds. Already question B we have solved, right? So that is very important. Here, this is the formation of sodium chloride. Next question. Sodium chloride ions being oppositely charged. So this is the ions being oppositely charged attract each other and are held by strong electrostatic forces of attraction to exist as a sodium chloride. It should be noted that sodium chloride does not exist as molecules but aggregates of oppositely charged ions. Yes, so these are the characteristics of ionic compounds that we have discussed already. Okay. Yes, these are the next question. Explain the electrolytic refining of metal. Here, many metals such as copper, zinc, nickel, silver, gold, so they are refined electrolytically. In this process, the impure metal is made the anode and the thin strip of pure metal is made the cathode. A solution of the metal salt is used an electrolyte. On passing the current to the electrolyte, the pure metal from the anode dissolve into the electrolyte and equivalent amount of the pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as a anode mud. Next question. Explain the extracting of metals from the top reactivity series. Please note down the question. Here, the metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with the carbon. For example, carbon cannot reduce the oxides of sodium, magnesium. This is because these metals have more affinity for the oxygen than the carbon. So, carbon is not used as a reducing agent. These metals are obtained by electrolytic reduction. For example, sodium, magnesium and calcium are obtained by the electrolysis of their molten chlorides. So the metals are deposited at the cathode, negatively charged electrode, whereas the chlorine is liberated at the anode. The reactions, so that is given here. So this is the reaction. Next question. In the electrolytic refining of metal M, what would you take as the anode and the cathode and the electrolyte? Here, in the electrolytic refining of metal M, impure metal is connected to the anode, pure metal thin sheet is connected to the cathode, and electrolyte is the acidified copper sulfate solution. Here, anode, that is impure metal M, and the cathode thin strip of pure metal M, electrolyte aqueous solution of salt of the metal M. Next question, give reasons. Platinum, gold and silver are used to make the jewelry. So let us see the answer for first one. Platinum, gold and silver are used to make the jewelry because they are shining metals and less reactive and they do not corrode easily. So that is the reason. Second one, sodium, potassium and the lithium are stored under the oil. Sodium, potassium and the lithium are stored under the kerosene because sodium, potassium and the lithium are highly reactive metals. These metals react so vigorously that they catch fire if kept in open. Hence, to protect them and to prevent accidental fire, they are kept immersed in kerosene oil. So that is the reason. Then, aluminium is highly reactive metal, yet it is used to make the utensils for cooking. Aluminium is highly reactive metal. It does not rust because it combines with oxygen and forms the aluminium oxide. The protective oxide layer prevents metal from further oxidation and aluminium is light, good conductor of heat. Hence, this is used to make utensil for cooking. And the fourth one, carbonate and sulfide ores are usually converted into oxides during the process of extraction. See the fourth one here. The metals in the middle of the reactivity such as iron, zinc, lead, copper are moderately reactive and these are usually present as the sulfide or the carbonate ores. So it is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. Okay, so that is the reason. Next question. When a calcium metal reacts with water, the liberated hydrogen gas does not catch the fire. Then second one is ionic compounds have high melting and the boiling points. Let us solve the first one. The heat is liberated not sufficient for the hydrogen to catch the fire. So second question, ionic compounds have high melting points and the boiling points here because there is a strong inter-ionic force of attraction present between the ionic compounds. So the more energy is required for the breaking down of that bonds interionic attraction. So the ionic compounds have high melting points and the boiling points. Okay. Next question. Give the steps involved in the extracting of metals, low and the medium reactivity metals from their respective sulfide ores. Okay. Please note down the question. When low and medium reactivity metals are extracted, an individual sulfide ore is first heated in the air. This helps in obtaining the oxide of the metal. It is easier to extract the metal from its oxide than the sulfide. Here mercury is a metal, low reactivity. So mercury sulfide is heated in the air and the sulfide or mercury is reacted with the oxygen. After that, mercury oxide is reduced to obtain the mercury. So here that is reduced. The zinc is a metal of medium reactivity series. It is present in the form of zinc sulfide and zinc sulfide that is converted into zinc oxide in the presence of the oxygen and heating, that is the roasting process, and zinc carbonate that is converted into zinc oxide in the presence of the oxygen. So this zinc oxide obtained is reduced to zinc metal by heating with the carbon. So that is the reducing agent. So pure zinc metal is obtained here. Okay. So this is how the metals are obtained by different methods. Next question. So give reason. Reactivity of aluminium decreases if it is dipped in the nitric acid. Carbon cannot reduce the oxides of sodium and the magnesium. Sodium chloride is not a conductor of electricity in the aqueous solution or as well as molten state. Iron articles are galvanized. Metals like sodium, potassium, calcium and magnesium are never found in their free state in nature. Yes, answer for the first one. When aluminium is dipped in the nitric acid, a layer of aluminium oxide is formed on the metal. It happens because nitric acid is a potent oxidizing agent. The layer of aluminium oxide prevents further reaction with the aluminium. Second question, carbon cannot reduce the oxides of sodium and magnesium. Sodium and magnesium tend to react with oxygen rather than the carbon because sodium and magnesium are highly reactive metals. Hence, carbon cannot reduce the oxides of sodium and the magnesium. And the answer for the third question, ionic compounds do not, sodium chloride, that is the ionic compound, so that do not conduct the electricity at the solid state because they do not form the ions in the solid state, but in the molten state the ions are able to carry the which conduct the electricity. Next question, iron articles are galvanized. Iron articles are galvanized to prevent them from rusting because after the galvanization, the layer of zinc works as a protective layer. Then metals like sodium, potassium, calcium, magnesium are never found in their free state in nature. Last one. So what is the reason? Metals such as sodium, calcium, potassium, magnesium are highly reactive metals. Hence, they are not found in their free state. Okay. Yes. So that is the answer. Yes, dear students, we have solved the almost important question from this chapter. I hope these questions are very useful for your board exam preparation. Thank you.